For the first time in history, an intact Starship is floating in the ocean. It didn't explode, it didn't break apart, it's in the Indian Ocean, still cheerfully sending live images even from the water, and is slowly drifting forward with the remaining thrust. Maybe we'll even see this prototype on display as a museum piece soon. But most likely it will be taken apart by the engineers and meticulously examined. At this moment, Starship is literally a ship for the first time. And as if that wasn't enough, this flight also deployed the first real Starlink satellites of the new V3 generation. An engine was reignited in space, which could be seen from the ground in South Africa, and a heat shield was brought back with so few missing tiles that you could count them on one hand. Out of 18,000. But, and this is part of an honest assessment, the same flight also cost a booster. That's the complete analysis of Flight 13. Second by second, with everything that went well, everything that went wrong, and what's coming next. And that's a big one. My name is Serwan, and this is Mars Chronican. Before the rocket even took off, this flight had already burned through 2 attempts, and both were educational. Let's start on July 10th. On that day, Booster 20 performed a static fire on the launch pad for almost a full minute with all 33 engines. And the footage is so powerful that you can literally see the pressure waves from the sound traveling through the air. All engines ran smoothly. 6 days later, on July 16th, the first launch attempt. The countdown went smoothly, the rocket was fully fueled, the ignition sequence began. And then, exactly at T-0, the onboard computer aborted. It had detected a non-nominal ignition in 4 of the 33 engines. And the launch rule is clear. A maximum of 2 engines may be missing at liftoff. 4 is too many. So abort. What's important is that this wasn't an emergency shutdown amid chaos, but a controlled shutdown. An emergency shutdown can actually cause damage to the engines. 29 already running Raptor engines were safely shut down. The rocket and the launch pad remained undamaged. What happened? The cause was in the oxygen turbopumps. Those are the pumps that pressurize the liquid oxygen in a flash and feed it into the engine. With 6 engines, these pumps showed an off-nominal rotational response. So they didn't spin as fast as they were supposed to. According to SpaceX, the most likely cause. Moisture had accumulated in the pumps from previous operations, and when the cryogenic fuel was introduced, it froze. The ice slowed down the pumps or blocked them completely. So there was no damage to the engines themselves, it was an operational error. Scott Manley gave the best explanation for this. When you burn methane, you get water and carbon dioxide. And both can freeze into ice. SpaceX uses exhaust gases, among other things, to pressurize the tanks. And that's exactly why, according to Manley, this isn't a one-time slip-up, but a long-term issue. Anyone who reuses an engine every hour must make sure that the combustion products from the last flight don't block the valves and turbines for the next one. SpaceX responded pragmatically. 6 engines were replaced with units that were already in stock at Starbase. One of the removed engines was strapped onto the test stand in McGregor and completed a full booster ascent burn there. The following Wednesday, a test was conducted on the pad in which the oxygen pumps of all 33 engines were spun up while in a chilled state. And there's something else worth noting, SpaceX didn't just present the abort not just as a mishap, but as a win. And there's actually some truth to that. It was a real abort under actual conditions, during one of the most critical dynamic phases ever. And the safety mechanisms worked exactly as designed. Entire teams of hardware and software engineers come up with worst-case scenarios for situations like this. On July 16th, one of them was unintentionally put to the test, and it passed. The second attempt on July 23rd then fell victim to the weather. But not in the way you might think. It wasn't due to launch restrictions, but simply because of visibility. Too many clouds. Because one of the main test objectives of this flight was to capture crystal clear footage of the heat shield during ascent using long lens cameras. And that's not possible if clouds block the view during the critical phases, and in the process, SpaceX dropped a bombshell. Almost as an aside, Starship is now theoretically allowed and able to launch in a thunderstorm. After extensive tests and analyses based on the certification logic of aviation, launching during lightning conditions is legally permitted.
The reason is strategic.
If you want to fly on schedule like an airplane, you can't stay on the ground for every little cloud. They said they would use the capability carefully, but it exists. That's a remarkable milestone that almost went unnoticed in all the commotion.
And one more detail about the launch preparations.
The countdown now has a new built-in hold point at T-minus 60 seconds. Previously it was at T-minus 40 seconds. There, SpaceX can pause for 5 to 8 minutes if needed, mainly limited by the propellant temperatures, and even after passing that point, they can reset back to T-minus 60 seconds. There is only one thing that can't be reversed. From T-minus 17 seconds, the water deluge system of the flame deflector is activated. From that point on, any hold automatically means a scrub for the day. Speaking of the flame deflector, SpaceX just showed in its documentary series what this component has to withstand, and there's one number from it you have to hear. At liftoff, about 29.5 tons of propellant per second pour out of the engines with over 8,000 tons of thrust. The engineer in the video puts it this way: imagine the biggest machine gun in the world. Except instead of bullets, it fires 11 Ford F-150 pickups per second out of the back of the rocket. Only one thing can really withstand that: water, about 2.4 million liters. That's a whole Olympic swimming pool. It evaporates in about a minute, because evaporating water absorbs a huge amount of energy. Now let's move on to July 24th. Friday evening, 5:51 p.m. local time in Texas. Blue sky. Not a cloud. The range in the Gulf and in the Indian Ocean is green. And then at T+0 it lifts off on all 33 Raptor 3 engines. And with a force that surprised even many spectators. SpaceX briefly showed a direct comparison of the 3 Starship generations right before launch, and the difference is brutal. Version 3 practically jumps off the ramp, while version 1 from Flight 1 still crawled up quite slowly. At T+20 seconds, you can see the shockwaves traveling through the air. In the first minute, the roll maneuver is wonderfully visible. And now comes a detail that sets this ascent apart from all previous ones. And that came from Elon Musk himself on X. This flight was intentionally flown with significantly higher acceleration to test how well the heat shield tiles stay attached under high dynamic pressure. Max Q, the point of highest aerodynamic stress, just after the 1-minute mark was therefore higher than in any previous Starship flight, and that was fully intentional. Musk's conclusion in the same post: test successful. At T+2 minutes and 5 seconds, we get the camera view inside the booster's engine bay for the first time. And the Raptor 3 engines are glowing cherry red in some spots, which looks dramatic, but it's nominal and doesn't cause any problems. At T+2 minutes and 18 seconds, stage separation begins. The booster sequentially throttles down all engines except for 5 of the central 13. You can literally see how the glow in the left image decreases, while at the same time the 6 engines of the upper stage ignite. At T+2 minutes and 32 seconds they have ignited, and the 3 central engines swing inward to push efficiently. That's hot staging in its purest form. The upper stage pushes itself away from the booster with its engines running, while the booster is pushed into a controlled flip downward by staggered ignition. And here's an urgent recommendation for all of you. SpaceX later released footage of the stage separation from the tip of the booster. You can see the ship flying away with 6 engines burning, while the exhaust plumes of both vehicles crash into each other and form a real ring of fire in the thin upper atmosphere. Nothing like this has ever been seen before. The astrophotographer Andrew McCarthy even photographed and filmed exactly this moment from the ground. And Scott Manley summed it up perfectly. This is what happens when one flamethrower hits another flamethrower. And then came the moment when Flight 12 failed, the boost back burn. The braking maneuver that makes the booster turn around. This time, all 33 engines ignited at first, then the sequence throttled down to 13 as planned, the maneuver burned cleanly through and was completed normally. This is exactly where everything fell apart during the last flight. This time it worked. The most important setback from Flight 12 has now been dealt with. The booster reached the peak of its trajectory at 95.6 kilometers around T plus 4 minutes and then fell ballistically back toward the Gulf. At T plus 5 minutes, there was a magnificent full-frame shot from the booster camera, with Starbase in the background and the launch's steam cloud casting a shadow on the water. Then the landing, and here things turn grim. The booster steered precisely through the atmosphere with its 3 grid fins, enlarged by 50%. And at T plus 6 minutes 26, the landing burn began. 13 engines were supposed to ignite for this. They didn't. According to the evaluations now available, only 8 out of the 13 ignited, and of those, 3 failed again after just a few seconds. So, effectively, only 5 were braking at times. The booster slowed down, but not enough. And at T plus 6 minutes 41, the connection was lost. A fireball marked the hard impact in the Gulf. Important to note, the booster came down exactly in the pre-cleared zone, a few miles off the coast. No one was ever in danger, and now the insight from Scott Manley, which shows how close it was. He recorded the telemetry from the last few kilometers, and he calculated a deceleration of about 25 meters per second squared and an impact speed of roughly 160 kilometers per hour. His calculation resulted in the following. If the booster had started the landing burn just 100 meters higher, it would have reached 0 exactly above the water's surface. So it's not a miracle that's missing, but fractions of a second of braking power. Because only 5 engines were firing instead of 13. By the way, just before T plus 8 minutes, the sonic booms from the returning booster came through the microphones at Starbase. An audible greeting from the booster that almost made it. So the honest assessment of the first stage is boost back repaired. A huge step forward, but reignition under landing conditions remains a minor issue for the Raptor 3. First, ice in the pumps on the ground. Now, ignition failure during flight. The pattern has a common denominator, and that's called reignition. The upper stage is completely different, and from here, this flight becomes the stuff of dreams. Ship 40 ran all 6 of its engines flawlessly. At T plus 8 minutes and 6 seconds, engine cutoff occurred at 26,412 kilometers per hour at an altitude of 148 kilometers, followed by the call confirming nominal orbit insertion, with the trajectory intentionally remaining just below orbital. So the ship came down over the Indian Ocean in any case. Under the freshly applied S40 lettering, beautiful temper colors could be seen on the stainless steel. Anyone familiar with steel can tell from this what temperatures this ship has already experienced during ascent. There were 2 small blemishes. At T plus 9 minutes, a heat shield tile came loose and flew alongside the ship for quite a while. At T plus 9 minutes 19 a second, apparently complete tile followed. Remember these 2, they'll be important again at the end. Then came the next first ever moment. At T plus 15 minutes and 18 seconds, the payload door opened. And for the first time ever, a Starship deployed real satellites. 20 Starlink version 3 satellites. No dummies like on Flight 12 and before, but fully functional satellites stacked in 10 rows of 2 each and pushed out one after another from the so-called PES dispenser, named after the Bombo dispenser. Because the trajectory was suborbital, these satellites only had about 20 minutes to live before they re-entered the atmosphere with the ship, and that was exactly the plan. A speedrun test program. deploy solar panels, fire engines, activate antennas, test laser links, and contact ground stations. The deployment lasted until about 27 minutes and 30 seconds, and at T plus 21 minutes and 50 seconds, 17 were out. The last 6 carried engineering cameras with long focal lengths and spotlights. More on that in a moment. At this point, a brief explanation of why these satellites are such a big deal. Version 3 is a monster. Up to 1 terabit per second downlink and 160 gigabit uplink per satellite. That's about 10 times the downlink and 22 times the uplink of the current version 2. Each one carries 6 high-performance lasers with 400 gigabits each for the laser mesh network, 4 quad-band radio antennas and solar panels that are twice as powerful. A single Starship launch with V3 satellites increases the Starlink bandwidth as much as about 20 Falcon 9 launches with version 2. Let that sink in. One flight replaces 20. And in the future, a Starship is supposed to carry up to 60 of these satellites, so that's a stack of 30 double rows. Because someone in the comments is guaranteed to make fun of the small payload door again. This opening is about 1.5 meters high. It only looks tiny because the ship is so absurdly large. A single one of the stainless steel rings that a Starship is made of measures over 2 meters. Most of the satellites that are built today can fit through this door. For really large payloads, there will be a bigger opening later on. And then came the news that made everyone in Hawthorne cheer. SpaceX established contact with all 20 satellites. And just minutes after deployment, the laser links to all 20 were also up and running. All tests, all satellites within a 20-minute window. By the way, the entire transmission of the flight itself was done via Starlink, with about 240 megabits per second data rate from the ship, where traditional spaceflight systems transmit in the single-digit range. Now to the maneuver that sparked speculation during the live stream. After deployment, Starship began to slowly rotate around its own axis. During the live stream, I speculated that the ship was turning its belly toward the satellites so their cameras could scan the heat shield. And Scott Manley confirms exactly that. He calls it the beauty roll, a pirouette in space, so that the 6 camera satellites with their spotlights can photograph all sides of the heat shield. Because the ship was now flying on the night side of the Earth, at T plus 33 minutes, you could even see how the spotlight of a Starlink illuminated the hull. At T plus 34 minutes and 35 seconds, the inspection was complete and the lights went out. SpaceX later released the full video of this inspection, including the pirouette. And it's remarkable how well the heat shield tiles held up. In fact, only a few tiles are actually missing. The purpose behind it is serious. Before attempting a real catch at the tower, SpaceX wants to be able to inspect the heat shield after ascent and before re-entry from space. An additional layer of safety that has never existed before. As a nice detail, bluish glowing dots could occasionally be seen at the top left of the image. Possibly the freshly deployed satellites, that's Manley's guess, already during the test firing of their ion thrusters. At T plus 38 minutes and 58 seconds, the test was scheduled. Scott Manley rightly calls it the most important of the entire flight, and he's right. The reignition of a Raptor in space. At T plus 39 minutes and 1 second, one of the 3 central engines ignited for an unusually long time, about 14 seconds. Why is this so crucial? Because SpaceX can only send Starship into a true orbit once this ignition works reliably. Without a functioning deorbit burn, a Starship in orbit would be a 100-ton piece of space debris that would come down uncontrollably somewhere and partially survive re-entry. Flight 12 didn't pass this test. This time, it was perfect. And the footage at T plus 3908 is some of the most beautiful this program has ever produced. At an altitude of 141 kilometers, there's practically no atmosphere left. But at 26,500 kilometers per hour, the remaining air molecules are enough for the exhaust plume to collide with them and create a comet-like glowing structure. The spectacle was so bright that observers in South Africa could see it with the naked eye from the ground and even filmed it. Take a look at this. Let's take one more quick detour, because SpaceX included it in the stream themselves. The new AI satellite constellation now officially has a name, StarMind. Up to 1 million AI satellites are intended to operate as orbital data centers. And SpaceX mentioned 3 bottlenecks on the way there during the stream: mass to orbit, for which there's Starship, energy, for which there's constant sunlight in space, and chips, for which the planned terafab with around 9.3 million square meters, the size of 10 gigafactories, is intended. SpaceX believes that computing power from space will become the cheapest option overall in 2 to 3 years. We've dedicated a separate video to the AI-1 satellite and this entire plan, which I'll link for you below. That's why we'll just make a brief note here that the rocket you're seeing fly right now is the foundation of exactly this plan. A quick aside about our own stuff, and I'll keep it brief. If this analysis has grabbed your attention so far, please show the video some love. It's just one click for you, and it makes sure that YouTube shows the video to a lot more people. And if you want to wear the Per Aspera Ad Astra spirit, you'll find the embroidered Ad Astra collection in our Planet Pioneers shop. The link and discount code are in the description below. Thank you, and now hold on tight. We're heading back into the atmosphere. Reentry began as a play of colors. At T plus 42 minutes and 51 seconds, the first plasma formed at an altitude of 105 kilometers at a speed of 26,700 kilometers per hour. In red, pink, orange, green, and dazzling white. At T plus 43 minutes and 50 seconds, a massive lightning bolt flashed deep below through the clouds, roughly over Madagascar, as if the planet were waving back. At T plus 44 minutes and 49 seconds, the official call-out came: Starship is beginning re-entry. Status nominal. At T plus 47 minutes, the report followed. The control surfaces have taken control of the ship, and that's at an altitude of 84 kilometers. At almost 26,800 kilometers per hour, the atmosphere up there is extremely thin. But at this speed, it's already enough for the 4 flaps to have full control authority. And now, the honest list of observations. Because it's important to stick to the facts, even in a dream flight. At T plus 49 minutes 19, turbulence appeared in the plasma stream. Visually spectacular, whether intentional or harmless can't be determined from the outside. From T plus 50 minutes, small sparks occasionally flew off the tail. And sparks always mean that material is being worn away and burning somewhere. The goal of a perfect heat shield is exactly the opposite, that nothing burns. At T plus 52 minutes and 23 seconds, the tiles above the right lower control surface began to glow. One of the most critical points of the entire ship, where previous wings have burned through. This time, to say this up front, it only glowed. At T plus 56 minutes and 56 seconds, clouds appeared in the image again. The ship was approaching the day side. By this point, it had already reduced its speed by about 10,000 kilometers per hour. And it was still flying at about 7,500 kilometers per hour at an altitude of 57 kilometers. Right in the phase of the strongest deceleration, when the plasma glows the brightest. From T plus 58 minutes, the glow became weaker. At T plus 59 minutes, it was almost delayed. And in the clouds below, the rising sun was reflected in red and orange hues. Kitsch that you couldn't imagine being any more beautiful. I say that in every Starship analysis. So once again, we have the most beautiful planet by far. So be good to each other and to it. At T plus 1 hour and 30 seconds, the ship passed through the point of maximum aerodynamic stress during re-entry. After that, the structural load drops rapidly because the speed decreases faster than the air gets denser. Then came a maneuver you should remember, because it's a dress rehearsal for the future. At about 1 hour and 50 seconds, Starship intentionally tilted to one side and flew a gentle curve. There was a wonderful call-out on the radio. Starship is executing the swoosh maneuver. The reason behind this is serious too. During future tower catches, the ship will approach from a slightly offset direction and will have to swing its flight path around on final approach. This exact curve was practiced here over the open ocean, nose slightly down, control surfaces to the right. Wonderfully visible on the position graphic at the bottom right of the stream. And Scott Manley adds the physical reason why this only happens late. The slower the ship, the tighter the possible turning radius becomes. At T plus 1 hour, 4 minutes and 28 seconds, the counter-correction to the left followed. The ship, as Manley put it, was chasing its imaginary tower in the middle of the Indian Ocean. And then the finale. At T plus 1 hour, 5 minutes, 4 seconds, at an altitude of about 1 kilometer and at around 400 kilometers per hour, all 3 central engines ignited. The ship pulled itself out of the belly flop into a vertical position, and the roar of the Raptors in the recording gives you goosebumps. You'll hear it in the original audio.
3 sea-level engines lit. We've seen healthy chamber pressures on them. We did our flick down to 2. Starship descending into the Indian Ocean. Down to 1. And we're in the water. And it's a soft splash down in the water.
There was a slight overcorrection when straightening up, along with an immediate adjustment. This has happened on every flight so far and seems to be normal. At T plus 1 hour, 5 minutes and 15 seconds, one of the orange buoys that SpaceX had previously placed in the target area flashed through the frame. And that alone is quite something, because if a buoy appears in the camera image, it means the ship landed exactly where it was supposed to. Later, we also got to see the footage of the buoys. The engines shut down in sequence. First one, then at T plus 1 hour, 5 minutes, 21 seconds the second one, and a single Raptor gently set the ship down on the water. Then engine cutoff. And what happened next hadn't occurred in all 13 flights. Starship tipped over and didn't explode. It didn't break apart. On Flight 12, SpaceX was still experimenting with a roll program to cushion the splashdown. This time, a completely intact Starship was suddenly upright in the Indian Ocean. Small fires from the burned-off leftover fuel on the hull. At that moment, for the first time in its existence, Starship was literally a ship. SpaceX spokesperson Dan Hewitt audibly lost his composure live. "I think I'm losing my mind right now," he said. "This is the first time we've brought an intact Starship down into the water. This is a dream scenario." It was, in his words, the softest splashdown this program has ever seen. Now it's about to get even better for the engineers. The cameras on board simply kept transmitting from the water. At times, even from underwater. The camera on the front control surface dipped in and out of the water. It was like a GoPro at the swimming pool. The audience immediately nicknamed it Nemo Cam. Even the camera in the partially flooded engine bay delivered images. The Raptors there were in good condition, with layers of frost on the central engines because they were cryogenically chilled during operation. Scott Manley rightly wondered how the ship was still transmitting at all. The Starlink antennas were ultimately pointing into the water. Possibly the connection was routed through the nearby buoys, and the ship's position was still being updated hours later. And the story continued even after the stream, in a way that even I hadn't expected. When the audience asked me during the broadcast if I thought this ship would be recovered, I just waved it off. But Ship 40 simply refused to sink. The tracking footage showed it about 160 kilometers from the actual splashdown site, still drifting. 56 hours after splashdown, and right next to it, the recovery ship Goa Australis. SpaceX itself confirmed that the recovery team is still collecting footage of the vehicle, which is still floating in the Indian Ocean. So, the dream scenario of a soft splashdown turned into a full-scale recovery operation over the course of several days. With an intact Starship that has attracted its own recovery ship, and now, if I may, I'll allow myself a little speculation, which I want to clearly label as such. If this ship is actually towed ashore, then we're not dealing with just any wreck, but the first Starship in history to survive a complete flight, including re-entry, and remain intact. That would be a museum piece of inestimable value. A dedicated rocket garden is currently being built at Starbase, an open-air exhibition of historic flying machines. And I can hardly imagine a more fitting first exhibit than this very Ship 40. Whether it will happen or whether export controls and logistics will get in the way in the end, we'll see. The engineers would probably also prefer to be allowed to take the ship apart. But the very fact that we can even seriously ask this question at all is perhaps the strongest symbol of how far this one flight has brought the program. Which brings us to the real treasure of this flight: the heat shield. A drone from the recovery team flew in right after splashdown, and because the ship had tipped onto its back, the belly with all around 18,000 tiles was exposed to the sky. The result? You can literally count the missing tiles on one hand. Do you remember the 2 tiles that came off at T+9 minutes and 9 minutes 19 seconds? At the stream timestamp of 1 hour 45:06, that's the stream time, not the flight time. You can see in the close-ups some broken tiles and 2 completely missing ones on one of the lower control surfaces. So that matches almost 1-to-1 with what flew off during ascent. In addition, there are white streaks running across the shield. And here comes Scott Manley's observation again. Almost all the streaks start at tile boundaries, especially at the leading edges. This suggests that hot gas is getting under the tiles and pulling out the white backing material, like felt or ablative material. In the footage of the control surfaces, you can also see that this white residue washes off easily with water. And don't forget, all of this happened after an ascent with intentionally increased dynamic pressure. So the shield was put through more punishment than ever before and still came back this clean. The heat shield also had pressure sensors that measured the stress during ascent. Musk's comment the day after: "The latest heat shield design looks great." After years in which these very tiles were perhaps the biggest open question of the entire program, that's a statement with weight. Finally, my assessment. Flight 13 is the most valuable flight of the entire program so far. And not because everything worked out, it didn't, but because of the quality of what did work out. The upper stage achieved everything that was missing for the next step in a single flight. Flawless ascent, real payload deployed, and contact established with all 20 satellites including laser links. Restart in space proven, practiced the capture approach maneuver, and delivered a heat shield that allows for a complete inspection. Because the ship has remained intact for the first time. That's exactly why Elon Musk made the announcement that same evening. As long as the data analysis doesn't reveal any problems, SpaceX will try to catch the ship with the tower on the next flight. Catching the upper stage with the tower. That would be the most spectacular maneuver this program has ever attempted. Probably even the most spectacular thing any space program has ever pulled off. The booster, on the other hand, got its homework back marked up. Boost back yes, landing no. 5 out of 13 engines are not enough. And as for the question of catching a booster, SpaceX is currently keeping quiet for good reason. Although they've already proven booster catching 3 times, if the technology holds up on version 3 now, then catching it shouldn't be a problem anymore. The pattern of version 3 is clear after 2 flights. The ship is the model student. The booster struggles with reigniting its new engines both on the ground and in flight. And then there's the most intriguing unanswered question of all. What actually happens now with the floating Starship 1,000 kilometers off the coast? Write your thoughts about it in the comments. I confess I dream of the exhibition. Lucky number 13. That's what SpaceX named this flight themselves. For once, there's actually something to that superstition. My name is Serwan, and that was Mars Chronican. Thanks for tuning in. Per Aspera ad Astra.